Hi.
Hey.
Going.
Hello?
Can you hear me? Can you hear me?
Yeah, I can hear you now. I think there's a little bit that caused issues.
Oh, okay, that's fine. Cool. Are you ready to interview?
Yeah, go for it.
Okay, so I presume you're going to be using Python 3.
Yeah.
And so how long have you been? Are you currently now like working, or are you just like a recent graduate, or have you been working as a developer?
Yeah, so to give you a little bit about my background, I've been working since graduation, and that graduation was in the spring, so I'm pretty much a new grad. So graduated in 2018 spring, started around September, and
Okay.
I'm using interviewing.io to...
Did you study computer science?
Sorry, what?
What's your degree in computer science?
Oh, so my degree was in chemical engineering with a minor in computer science.
Oh, okay.
Yeah.
Cool. All right. Well, on that note, I think I'll start by asking a question.
All right, sounds good.
Let's see. Okay. So this question. So I have this tree structure, and every element in the tree structure can be either an operation, like plus, minus. It's actually going to be one of 4 operations. Plus, minus, multiplication and division, and so every node can be a operation, or it can be a integer. So
Okay.
and I want to find the result. Yeah, evaluate this expression. So like as an example, like the tree that looks like this, like 4 and 5 would return 20, and then so times 4 and 5, and then maybe like 1 minus yeah, shouldn't matter. 1 minus, let's see, 2 minus 1. This would actually be 2, 1. Okay, so I might want to space this out a little better.
Yeah, I think it'd be much clearer if I could figure out like who's the parent and child. Okay.
Yeah. So like that kind of thing. This one would be 4 times 1, or 4. Yeah, sorry.
Wait, so is the 1 the child of the minus, or who is
this? How does this work? Hold on. I've asked this question before. I don't know why. So times 4 to 5 minus 1. Okay, scratch this question. I thought I knew this one a little better. I don't know it. Okay.
Okay. No worries. I mean, I was going to like divide the thing. Yeah.
Okay, here's a much easier question to understand, and for me to understand actually. So you have this like 2-dimensional matrix, and in it there are colors. So like there can be like 3 colors, like red, blue, or green, and every entry in this 2-dimensional matrix is a color, and you want to find the biggest group of colors that are touching each other. So let me see if I can draw the matrix like that. So I'll just do it without. So like a red, blue, 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 green, red, blue, green, green, red, and then red, blue, red, red, green. So in this matrix, I guess blue, there's 5 that are like continuous and touching. So you would return the color that constitutes the biggest group.
Yeah, that's fair. So there's two ways you can do this. One is union find. And with union find, you'd have like a dictionary, and whenever you join it, you just add up the sizes of the two groups that you're joining. The other one is a depth first search, where you for each node, and you would mark each node after you visit it in the depth first search, but you basically just go through and like each time that you see one of the same color, add one and visit that one, and just recursively visit all its neighbors. So I mean, we can do either, but those are, to my knowledge.
So okay, have you seen this one before?
So full discretion, I've probably seen like 750 LeetCode questions at this point in the last 4 months.
Oh my god.
Yeah.
Okay.
Yeah. I have an on-site with like Google on Monday, and so I've been prepping like fucking crazy.
Oh wow, that's incredible then.
Oh yeah. Also for your binary search question, your binary tree question earlier, I think would be like divide and conquer, right? Like you'd evaluate the left side of the tree, evaluate the right side of the tree, do whatever the notation tells you to, and then return it.
Okay, cool. So maybe I'll find a more difficult question. Let me think.
I don't know if I dug myself into a hole now, but.
Wait, I'm sorry. What did you say?
I don't know if I dug myself into a hole now, because I don't know if I want to super.
Oh no. Well, I mean, if you're not getting challenged, then there's no point. So.
Oh yeah.
Let me think. How did I do this? Sorry, I'm just looking over some questions I've written the solution to and trying to figure out if I can re-ask that same question. Okay, here's a good one. So you have an array of random integers, and you want to partition this array into you're wondering if you can partition this array such that the sum of the left elements is equal to the sum of the right elements. So okay. Let me write that out. Have you heard this one before?
I have not.
Okay, 6, 7, 8, and then like I'm not very good at math, so 5, 5, and 8, and then let's see here, 1, 2, 3, 4, 5, 3. Well, actually, this is too long. Let's make it simpler. 3 and 1 and 2. So this one's easy to partition because you can just put a partition between 3 and 1 and 2. So the left and right side are equal. And then you can also, obviously, you can have any arrangement. So 1, 3, 2. This is also true. But then something like this is false.
Okay.
So I'm going to write the solution for that second one here. Yeah, it's going to be the same as the first one. Yeah, let's just call the function partition.
Let's see. So it's kind of interesting. This is definitely one I have not seen before. So there might be a dynamic programming way of doing it. Otherwise, I wonder if so dynamic programming would probably be a more complicated way of doing it. And I think there is a way. But that being said, hopefully there's a simpler solution. And I like to explore that first, trying dynamic programming. So let's run through a couple of examples. I wonder if it would help. So there can be, multiple of a number, like duplicates, and there can be negatives and positives, right? So there's a basic one's range of whatever numbers you can have, right?
Oh, just presume they're all. You can presume they're all positive if that makes it simpler.
Let's see. So let me see if sorting gets us anywhere. So if I sort this one, I end up with a 2, a 2, a 3, a 3, a 4. Hmm. Okay, so now that I have this, can I figure out whether it's possible? Hmm.
So I think actually, I don't know how to solve this without dynamic programming.
Oh, okay.
So
Fair.
maybe it'd be worth exploring that route. Another way, I guess. Yeah. Okay. I don't want to interrupt you. I'm sure it is possible to do it without dynamic programming because you would just explore all possibilities multiple times. So.
Yeah, that'd be super expensive. So yeah.
Which is fine if you do it that way too. I don't really care.
All right. Yeah, we can try that as like a worst case, but I feel like the dynamic programming would be more interesting just to try out. So let's see. If we're gonna have dynamic programming solution, it would probably we would start off. Let's see. How do we want to frame the dynamic? I'm trying to think of the recursive relationship that you want to have because you probably start off with some base case, and then you'd like incrementally add each number and just sort of evaluate it and compare it to what you've already done, like your subproblems. And so I'm trying to think what would be the ideal base case. So let's say the different. So you start off with the let's say initially you process. How do we want to do this? I'm trying to think here. I think we want to have a dictionary, and each dictionary is going to have a list, or each dictionary would have a set. So this is how we would store our results. And then is equal to default dict set. So basically, the strategy I want to use is let's say we do like 312 as an example, right? Right. So when you initially start, you're going to, and let's say that you have like the left and the right, right? When you initially start it, you will have processed 0 elements, and you will have a difference on your left and right side of 0, right? And now you process your first element, so after 1 element. So now you process your 3, and with your 3, you could either be -3 or 3, right? And this
So what are these values?
So the recursive relationship is basically if you add it to, so I guess what's the value, if we're going to define that, is equal to left side partition minus right side partition.
Yeah. Okay.
So this would be an example of -3, well, actually 0, and then partition, and then 3, right? Because 0 minus 3, I mean, 0
yeah.
It would be -3, yeah. And this would be
so the value is the difference, the imbalance. How about that?
Exactly. So it's going to be your difference.
Yeah.
And you would do that by iterating through every value in the step before it. So I get the -3 and the 3 by adding or subtracting 3 from every value in the step before, so just like 0 layer.
Mm-hmm.
And then same for after 2. So it's -3 is going to become -4. So if I subtract 1, it could be -2 if I add 1. And then for this 3, it could be 2 or 4, right? And so I'm going to do this for every single step. Okay, apparently there are some shortcuts that have been added. So whenever I hit enter, they just automatically add them. At the end, I'm going to look at the set for my last row, and if 0 is in my last set, return true. Otherwise, return false. Does that make sense?
Okay. Yeah, that's great.
All right, so we ready to code this up then?
Well, that's up to you. But this does look good. This looks like the right way to go, I think.
Okay. Yeah, I'm trying to think if there's an edge case. I mean, I can tell you the runtime for this is going to be, let's see, it's kind of expensive actually now I think, but because it's like 2 to the n. Let's see.
Well, what's the max size of your? I guess you're storing these every row, so to speak. You're storing these result values. So what's the maximum size of one row?
I mean, so it looks like we double it each time, right? So for this one, we had 1 element, and then we subtracted and added for each element before, and so it grows by 2 by magnitude of 2. So the largest this is going to be would be like 2 to the n, n being how many elements you have. I mean, is that what we're going for, or are we trying to optimize it further down?
So that would actually be the runtime of if you didn't use dynamic programming. If you just brute force every possible partition, where every element can either be in the left side or the right side, then you have 2 to the n possibilities.
That's true.
Yes.
I think we just use a brute force, yeah.
So if you're doing this lookup table, then the whole goal, I mean, then you might encounter like some values that are repeat, so you don't have to keep traversing down that tree. So in this case, it will be a little faster.
Okay.
Or, I mean, I'm wondering maybe you could explain like how much faster it will be, or like what will be the runtime if we're using this dynamic programming approach.
So I mean, the idea of the set is, so for instance, if we, like, you do cut down on some of the branches. So for instance, if this was like a -2, right? Because our default picked the value is a set, you'd only go down one of these 2. You wouldn't go down both of them. But that being said, that's your worst case scenario would still be 2 to the n, in the case where you don't have those duplicates.
I don't think so. But
okay.
I'm only saying that because I haven't thought about this really in depth. So yeah, so maybe you're right. But I'm thinking like let me think. What am I thinking? Like okay, so for every row, like the number of possible values you could have at the very last row is going to be it could span from negative. The imbalance could be then like let's sum the whole array, right? So the whole sum of the array is going to be like 6. So at the end, every possible value you could conceivably have is from -6 to +6. So let's call that m. And then for every you're going to do every row, I guess you'll have like how many operations for every row? Or sorry, how many of these rows will you have?
You're going to have n rows because you're evaluating each element. Okay.
Yeah. So I'm just guessing that it would be like n times n size, or size of space, and then yeah, runtime. I don't know. Maybe it is 2 to the n, but I don't. It must be faster if it's dynamic because you're cutting off the branches. So
Yeah. I guess
yeah.
let's imagine like a worst case scenario where you were inputting something and for some reason like that input was tailored specifically so that you never got the same sum. I don't know if that's like maybe I was like that's a super worst case. That's like definitely not average case though.
Oh yeah. But okay, yeah. The reason why that can happen is because obviously negative m to positive m is going to be much smaller than 2 to the n. If n is like if n is 64, then 2 to the n is like a huge number, and then the biggest positive and negative value you could have is like just depends on the size of your max sum. So,
oh, okay.
I don't
Yeah.
know.
Okay, yeah, that makes sense. I guess mathematically, yeah, you wouldn't be able to do that then. All right, cool. That makes sense then.
Yeah. Okay.
But yeah, I guess as you pointed out, this would be like an MN space solution.
Mm-hmm.
So yeah, I guess we can code it up then. Let's see, so. So def and a array. And so let's see. To our default disk with each value being a set by default. And then we're going to add so that's our base case. Okay, so we value each time. Actually, I think about it. For I and enumerate. That way we can also get an index, and the index is going to be our key to our dictionary.
Okay.
Also, this should be add because this is a set, not a list.
Okay.
For I dictionary, and then for so technically, if we really want to optimize on space, we actually don't need to keep the entire dictionary with all the levels, because really all we care about is the current level and the level that came before it, right? Because we'll never reference beyond that point. That being said, we can probably just do this for now, because it doesn't affect the big O notation. But yeah, that's like a future optimization if we really wanted to do it.
Okay.
So for let's call it pre-diff, and that will get us all the values in the set that came the step before. Pre-diff, we're going to subtract lm, and then we're going to add lm. Okay. And that looks about right to me. And return section class 1 is going to be zero in. And that's pretty much it.
Wow. Okay. Cool. So Wow, that's pretty cool. You want to test it?
Yeah, sure. I'm hopeful that it works, but should be able to fix if it doesn't. So yeah, let's say test is equal to solution and print test dot partition par and 312. Oh crap! It didn't work. Oh, that's not good.
Oh, that's fine. I wonder why. So
Yeah.
is I don't know Python, but are the arrays start off at 1 or start off at 0?
The arrays.
Like the first your dictionary is, so when you enumerate the array, is
That's
the
good.
first I going to be 0 or 1?
That's a very good point. So it's definitely gonna be 0, but that's not what we want. We want I plus 1.
Okay.
So let me double check that. So for I element, we want this to be 1. Dictionary. I'm just gonna change that to. I don't really want to have to worry too much about the off by 1 errors each time. So yeah, let's see if that works now. Okay, so that seems to work.
All right. What happens if we do this? Nothing. Did it return? Is it still running? Oh, is this? I can't tell.
I think I hit it at the same time we did, and that might have
Oh,
caused
okay. Little bug there.
error or something back.
Yeah. Cool. Wow, that's great. That's a lot better than my solution.
I mean, is your solution, I guess, like if it's longer, is it more optimal or?
No, it's exactly the same algorithm. I think I just had to. What did I do? I'm like making sets. Hold on, I'm just reading because I only really know JavaScript. So let me see.
Okay.
I do exactly the same thing. Makes sense. Oh, in the end, I mean that's pretty much exactly what I have. I'll even copy and paste it. I just had to write this auxiliary function to. Actually, you might want to do that for practice, like to return the actual left and right sides of the partition.
Okay.
Because I mean, knowing whether you can partition is one thing, but actually having it is even better. So.
Yeah. So the question about actually having it, that's actually a LeetCode question. And so like the reason I was able to come up with this is it's very similar to that question. Because the one where you return the sizes, like on LeetCode, it's like a LeetCode hard, and yeah, it's basically that. And they do a similar solution where it's recursive, like it's like yeah, but it's a little bit more.
So how could you do it?
Yeah, so the way
I think you could actually do it without even modifying what you have now. You would just have to add to it.
Yeah. So you would modify it a little bit in the sense that, let's see.
Let me think.
See. So for each iteration, you would look at.
Yeah, you do have to add something extra. Sorry.
Yeah. Because you could, whereas with this one, it's like you have to. Oh, also, I guess this actually is different because in the LeetCode one, you didn't have to use all the elements, but in this case, I guess you have to use all the elements if you want to like strictly partition it.
I see. So in LeetCode, if you hit 0 at some point, then you just return.
Well, the LeetCode one is return the largest sum on each side where they're equal. And so you'd have like a max.
Oh.
You like constantly update
That is a little trickier.
Yeah.
Okay.
So yeah,
Well, that's
basically it.
fine. I'm sure you can think about that. So okay, now that we have a whole another 30 minutes, I was just going to take advantage of this and ask you another question, if that's okay.
Yeah, go for it.
Unless you're on a time crunch.
Oh no. It's more practice, so I'm grateful.
Okay, cool. So this one, okay, so you're in this city,
Okay.
and the city has all. Oh, sorry. You're in this country, and there's a bunch of cities in this country, like a handful of cities, and then there's a public transportation system, and they have bus routes, and the buses go in this like circle. It'll visit like city A, city B, city D, city F, and then back to A.
Okay.
And then there's like another bus that goes from like A to some other city, and then has its own cycle. And the question is, so let's say I have two cities. For any given two cities, is there a way to get from one city to the next by taking public transportation?
So it seems like that's a depth first search problem, right?
I don't know.
Okay. So to get a
How
better
would you do
idea,
it with depth first search?
to get a better idea of the inputs, so I assume I would be given like a list of lists, right? With each list within the larger list representing. So for instance, if I don't know what the input looks like, but I'm imagining it would look something like this, right? So let's say you have two cities,
Mm-hmm.
and so this one is gonna go to city one. This one's gonna go to city two. So it would just be like a circle, right? Like 0 goes to 1, 1 goes back to 0, right?
Okay. Yeah.
Or maybe this goes to like 2, and then this goes. There's a city 2, and this one goes to, I don't know, back to 1, right? So I'm assuming that's what the input would look like.
Wait. So sorry. Describe this again. So the first entry, this 1 and 2 is what?
So this is saying that because this is index 0, right? This is saying that city 0 has a path to city 1 and city 2, right?
Oh,
So
okay. Oh no, you don't have that. Sorry, I should be more clear about my. I'll give some input actually. Okay, so you have a bunch of buses. So bus one has visits these cities, 1, 2, 3,
okay,
right? And then bus two visits like 3, 3, 4, 5, and then bus three visits 4, 2. Let's think 4, 8, and 9. Sorry, yeah. I'm just giving the cities number names, which you have done so. Let me see. And then let's see. Visit bus. The next bus visits. I mean, so far now. Okay, yeah. Visits just 7 and 11. And the question is like, can you get from if you're trying to get from city 2 to city 11, can you do it?
oh, okay. So in that case, this is going to be a union join problem.
Hmm.
So what we're going to do in this case is, so this would be like one. So as a base case, I guess your first iteration through each bus route, that's going to be one like union, right? And this is going to be another union, and this is going to be another union. And then, oh God, that's actually going to be really, yeah. And so then you would, let's see, how would you do this? That's actually kind of tricky.
So what's wrong with the union approach?
So the union approach is really expensive, right?
Why is that? So tell me what you're unioning and like how you're doing it a little more in detail.
Yeah. So as an initial case, so let's see let's say that my parent is like the array where I'm keeping track of like which union it's in, right? So city,
Mm-hmm.
I guess we don't have a city 0 in this case. But so city 1, 2, 3. So let's say 1. Okay. And then.
So 1, 1, 1. So parent is what exactly? That's
So
like the root of the union set?
Like which union it's in, or like which group.
Okay.
So let's say.
Oh, you're storing it like in an array notation?
Yeah. So like that's how I usually do union joins. So this would be city 1, city 2, this is city 3, right?
Okay. Oh, I see. Got it. Yes.
Yeah.
Union on the cities.
So do I want to? Maybe I shouldn't do it initially going. So initially I was going to do it like, this is going to be one union, this is going to be one union, this is going to be one union, that's going to be another union. But maybe that's not the best way to go about it. Actually, let's see. So 3, 4, 5. If 3 isn't set, then find 3. Actually, okay, never mind. I don't think it's going to be expensive at all then. Yeah, it's not going to be that bad. So let's see. So these are all going to be in one set. Okay, and so when I get to the next one, that gets tricky because you immediately come across the 3, 4, and 5, and 3 is in both. So let's see here. I guess you could also have a set scene, right?
Okay.
So that sort of tells you whether you should check to merge groups. So initially for 1, 2, 3, like none of that has been seen before, right? And then in that case, you would just union join the whole row because that's like one bus route.
Yeah.
So also you would need to check. So for each bus route, check if any are in scene. Yeah, because if they are in scene, then you'll need to start joining them. Okay, and so I also probably keep that in a list because you might run into a scenario just for so for instance, like if we had a 4 and a 2 right here, just as an example, you would need to join it to 2 separate groups, right? Not just one. Yeah.
Okay.
Okay. So in this case, when we run across the 3, we see 3 has been seen before. And in that case, let's see. So if 3 has been seen before, also, are you still there?
Yeah. Oh, yeah. I'm still there.
Okay. Just wondering because I see like this blue tab across the top that says refresh the latest version, which I don't know what that means.
Yeah, I don't know what that means either. Okay.
Okay. Let's see. So if 3 has been seen, actually, do we want to union join?
So what are these union joins? Let's go. Actually, maybe you can describe your approach a little better. So like, what? So I guess you're union joining each, right? Okay. What exactly are you union joining and like why?
So I'm union joining the ones that have been seen before, because that way they will be in like the same grouping, right? And a union joining means that you can, within that group, go from a bus to any other city.
Okay, so if I go to like, if like, let's say you're union joining all the cities into different groups, right?
Yeah.
Is that what okay? And so then, if a city is in the same union set, then you can get between them.
Yeah, pretty much.
Okay.
Also, so there is a solution. So it would be n. So if n is the number of buses and then m is the number of cities within each bus route, we can probably do a union join that's n m squared time. I'm just trying to
Okay.
optimize down. But so like that would be probably the cleanest way.
Okay.
Yeah. So to explain the n m squared way of doing it, you would literally just go through every single combination. So I would start with this one, like 1, I would union join it with 2, right? Then I would union join it with 3, and so now all these are one grouping. And then for 3, this is why n squared is because you do this n times for the number of buses, and then within each bus route it's n squared, right? So I union join 3 with 4, and then I union join 3 with 5, and then I go down, I union join 4 with 5. Actually,
okay. Yeah.
how do I? Oh, okay, never mind. I don't need to do the pairwise thing. In that case, it's just nm time because they will already be in a union. Okay. Okay, yeah. I may have been overthinking this earlier. In that case, it's just nm.
Okay.
Um,
Okay. So what is the algorithm?
So to go, okay, yeah. So let's see if I can. Let's just start over here. So going to have a. Let's say we have the functions. Really, the only one that matters is union, right? And then also find parent.
Okay.
Actually, root is probably better, right? And so what we're going to do is for each row, and then for these for each row.
What is one row? Oh, that's each route. Each bus route.
For each bus route.
Okay.
We're going to union join everything. So first L equal to bus 0, and then for so basically that means like for every element after the first one, we're going
for every
to
city in the route.
Oh yeah, for every city.
Oh.
We're gonna first L, and then we can call it city. Yep, and then I will let us union everything. So to continue with the second row here, 3 is unioned with 4, so 4 is added this one, and then 5 is also unioned in. So
okay. And this second time you encounter 3 here, that's fine because it's already in the set. You're saying?
Well, so in this case, you don't actually need to have. I guess if you want to check for redundancy, that's okay. But you don't really have to have the set at all. The set doesn't actually matter.
Okay.
Yeah, because if we try to.
Yeah, because you already know you can. Yeah.
Yeah.
You check 3 and it already points to 1. So
Yeah. So it doesn't really matter. And plus, when we do the joining, we can probably have a check that's like if parent is already equal to like the same parent, then just do nothing, right? So that's another way to deal with it, just within the join method.
okay. So
yeah.
what happens when you hit 7 here?
So, also to clarify, the way the parent list is initialized is initial parent array is each element is just going to point to itself as its parent. So it would just be none.
Okay.
Yeah. So in general, for union joins, that's how you would initialize the array. Each node is like its own parent, and for unions, you would travel up to their parents and then set one parent equal to the other's parent, right? And so in this case, because 7 has never been hit, so when you hit the 7, you're going to join it with the 11, right? And so to finish this off, so the other elements, I guess, will be taken care of. And then if we decide to keep the 7, it would look like that, right? So 11's parent would be 7, and then 7's parent is itself.
Okay.
Yeah, and so I guess to finish it off, so these would all be in the same grouping. 6 doesn't exist. 7 also doesn't exist. 8 is in the same group as 4, and then 9 is also in the same group as 4. So then we would, at the end, find the parent of of 2 is the city we care about, and we find the parent of 7. Also by parent, I mean root. And so you find the root of the cities, and then you'd be like, oh, they're not the same, in which case they are not in the same group, and they can't, interact with each other. And so you turn false in this case.
Okay. Cool. I think that will actually work.
Yeah.
Yeah, sure. You want to try coding it up? I think it might
Sure.
need one little change, but yeah.
So let's say, okay. Call it reachable. And routes. Let's see. So and also I'm guessing the cities in the bus route can be any number, right? It can be like 1, 5, 100, 2,000, right?
Yeah. There can be any number of cities. They're really just names, so they don't have to be numbers. So.
Oh, okay.
Unique identifier for the city.
Yeah, I'm just making sure,
or you can just
Okay. Yeah.
Because you're using array integers. Yeah, just presume it's just integers. Like presume you pre-processed it and labeled all the cities with a number. Like
okay. Cool. Yeah.
Number.
Otherwise, I'd use a dictionary. I was just wondering, what the ideal item would be.
Yeah.
So
this is a bad input, actually. I'm gonna fix my question so that it fits down here.
Okay. Let's see. So, and if we can assume that, so we need to figure out how many cities we have. And so let's assume that we have, assume preprocessed, all numbers are contiguous.
Okay.
So we need to find, I guess, this is like a small first step. City is equal to 0 for bus. Right? So that'll get us the total number of cities. Well, yeah, total number of cities. Let's see. So if I have one city, and in that case, uh, 0, and then for the while loop, while city is less than or equal to Maccity. And let's see. Right, and so ideally that should set up our initialized array. So it'll look something like 0, 1, etc. to our Maccity. Right?
Sorry, what is Maccity? That's the root city?
So Maccity is just like the largest number that you have in your input. So for instance, if like the example that you pasted above, it would be 8, right?
Yeah.
Yeah. All it's doing is just telling us this is how large our parent array should be. And that's what I was asking earlier.
I see.
The numbers were contiguous or like preprocessed.
Oh.
Yeah.
Oh, I see what you're doing. You got to allocate the array. Okay, got it.
Yeah. And if it wasn't preprocessed, and that was like the point of me asking, if it wasn't preprocessed like that, like if this was instead of a 1, it was like 9999999, you would use like
yeah.
Right? Because you wouldn't want to have a list that would be mostly.
Okay. Thanks for that.
Yeah, I mean, you can obviously change this into like a dictionary if you wanted to. It's just, your preference for how you want to do it. But if they are contiguous, then like a list would probably be easier and faster access.
Yeah.
Okay.
Then a dictionary?
Yeah, because a dictionary is always going to be slower than a list, right? Because a dictionary like is a superset of a list, basically, right? Like it's like operations of a list.
So a list is like more restricted and more optimized or something?
Yeah, basically. Like it's impossible for a dictionary to be faster than a list because a dictionary does like list operations plus other operations.
Okay.
Yeah. I mean, it doesn't really matter for like a lead code type question. Yeah. Yeah. You will have set that up, and let's see. Our next step is. I'm just gonna try to find my place again because I got off on a tangent there.
Yeah, sorry about that.
Yeah, no worries.
But thanks for the knowledge.
Yeah. So for out and routes, first city to route 0, and then in that case, we have to define a couple of functions really quick. So defining, let's do parent first. And so parent of I. So while if parent root. If I is not equal to parent I, if it is equal to it, then you return itself. Otherwise, if you're trying to find the root, root. Okay. So what this is doing is this is going to find you the root of your current node, because it's basically just going to traverse up like different parents. And then also what it's going to do is it's going to, once it finds the root, it's actually going to assign it to the parent of this current node. And so not only does it find you the root, but also shortens down the height of that recursive traversal. So that the next time you do it, it'll just be like one step away. Does that sort of make sense?
I think so.
Yeah. It's just that in the future, if you ever want to find the root of this one again, like you will have updated it on line 86. And so you can like shorten the traversal a lot.
Oh, I see. Yeah.
Okay.
But isn't that what a union set is anyways?
So for a normal one, you wouldn't, so you would, so if, for instance, if I, instead of this one, I had like return So this is what you could do instead. This is like a lazy way of doing it. I think that it's taught in textbooks more. In this case, you don't cache it as a parent array. And so if you were to call root I on this one again, you would have to go all the way back up the tree. Whereas in this case, now you're only like one step away from the root, right?
Oh, I see. So that means, okay. Even in worst case, you're only like constant time away from finding the parent.
Yeah, exactly. You're like reducing the height of your tree, basically. Yeah. And then so def union, let's call it I and J. Parent I is equal to root I, and then parent J is equal to root J. If they're equal, you can just do nothing. Otherwise, let's say parent I is equal to actually just parent I. That might be easier for debugging later on, because we'll keep the first one that we encounter. But yeah, that seems good to me. So you have a root, a union. All right, and then at the end, you're going to return a root. Let's see. Oh, we need to have in our parameters source destination. So source equal to root dest, and that should be it.
Okay. I think that makes complete sense. So, and I don't want to keep you here too long. So, there's no need to test it. I guess you could do that on your own time.
Yeah.
Then, okay. So because we're out of time, there's even one more extension to this, which maybe you want to think about, which is like, how would you find like the shortest number of changes between buses? Like, let's say every time you want to get on a bus, it costs like $1.50 for a bus pass. Like, how can you do this with spending the least amount of money to get
Okay.
from city A to city B?
So that would be like a breadth first search. You want to store from each city. So you'd have to like pre-process your input array.
Mm-hmm.
And then basically you want to get into some part like the dictionary where like each key is a city, and then the value for that dictionary is a list of the cities that you can go to.
Mm-hmm.
And then basically just do like a breadth first search. And as soon as you are able to get that definition, you like, you just return the amount of stops it took.
Yeah, exactly. Okay, cool. Yeah. Thanks for taking the time to let me interview. I actually was anticipating that I was going to be interviewed today, so I was kind of surprised to learn that I had signed up to be the interviewee. But thanks for bearing with me.
I had a person and I asked them like, oh, describe like your background in detail. I had them describe it for like 5 minutes as I looked through these questions.
You had them what?
Oh, I had them like describe their background for like 5 minutes as I was like scrambling to find a lead code question for them.
Oh, okay, that's a good strategy. I'll keep that in mind if that happens to me again. Okay, thanks. Yeah, good luck on your interview.
Thanks. Do you have any feedback or like things to improve or?
Oh, yeah, feedback, of course. Yeah, so I think let me see. The first one was pretty good. I think the second one, if you could like articulate, I totally forgot about the feedback. If you could maybe spend even more time, like, or make sure that like exactly the algorithm you're going to use is like clearly articulated before you start coding. I think maybe you're fine there. Maybe it's just because I don't have super good familiarity with these questions I'm asking, that it was harder for me to understand your approach. And then another thing here, like, I mean, just like judging, I'm not a good judge of Python code because I don't know Python, but I think this like Maccity and this like this stuff here maybe could be like taken out or something. But other than that, I mean, I think these are really hard problems, and you figured out the algorithms very quickly. So I think, and then you were able to transform that algorithm into code. So I mean, I have no complaints there.
Okay.
I think it's perfect.
Yeah, really appreciate it. Oh, also, I noticed that you were, I guess, is union join not the way you're thinking of doing the second one? Because I noticed like, maybe you were like
no, that
approach.
So I've only ever thought about this problem like in like kind of like on my own time, but then I was thinking I would do like I would just like somehow like conceptually the idea behind it would be I would make a graph, and each node on the graph is the route, and so I would traverse each route. I would go through each route and then like make edges from one route to another route if they hit the same city, and then at that point, like you were saying, you could do a breadth first search across this graph to see when you hit a route that contains the city you're looking for. So somehow like that just seemed a little bit like higher level, like easier to understand than this union stuff. But I think the union stuff is actually maybe faster. I don't know. And maybe the union stuff is more natural to think about too. So I don't know. That's just how I was thinking about it.
Okay.
But I really liked this application of union stuff. That's really good.
Yeah, for the most part, whenever I've seen problems that can be solved with union join, they can also be solved with depth first search. And so, yeah, I could definitely see what you mean. Like, you process the routes, and then if it's like in the same route, then you would add an edge between those two cities. So yeah, that definitely makes sense. You definitely do it that way.
Yeah, and also I'd never heard of this union thing for the what was the other one you did a union for? Oh, it was my first question on the matrix, the colored matrix thing. So that was a really cool approach too. So maybe I'll think about using that more if I'm tempted to do a depth first search, then maybe I'll think about a union set next time.
Okay. I mean, to be honest, I feel like depth first search is a little bit cleaner because like with the union join, you always have to define like the root method and the union method. And so that's a little bit of overhead. But also like once you copy and paste it like a million times, you kind of know what it looks like.
Yeah. Cool. Yeah, that was a really good interview. Thanks for working with through these things with me. It was very helpful for me too. So yeah, good luck. Enjoy your practicing.
Yeah, appreciate it. Thanks a lot for your
Bye-bye.
time. Really good questions. Hope you have a great one.
Yep.
Um,